Hey, this is Dr. B, and we're looking at page 4 now of the bonding practice test. Question 19. Here's the electron dot structure for diatomic bromine. There you go. With circles showing 8 electrons around each bromine atom, 2, 4, 6, 8, 2, 4, 6, 8. It's very informative. What does it tell us? Well, I hope it would say that by sharing 2 electrons, you form a covalent bond between bromine, and each bromine atom can fulfill its octet. It has its 8 valence electrons. Let's see if they say that. Each bromine atom contains 7 valence electrons. Well, it does originally, but then they form an ionic bond when they share 2 electrons. So close, but it's not an ionic bond, it's a covalent bond. Each bromine atom contains 2 valence electrons. They share 2, but they have 7 when they enter the game. 2 bromine atoms can form a noble gas configuration by sharing 8 electrons each. They obtain 8 electrons each, but they're only sharing 2. Each bromine atom contains 7 electrons. It does, including 3 lone pairs. It's true, and then they form a covalent bond by sharing, yes, 2 electrons. Perfect. I like D. The ammonia molecule has the bond lengths and angles shown. It's a trigonal pyramid. Aluminum chloride, on the other hand, which, by the way, doesn't have that lone pair. NH3, see the lone pair because of 5 valence electrons of nitrogen? Aluminum chloride, I can see where they're going with this. It's going to be very different. Let's see. On the other hand, it has a flat trigonal shape. Yeah, because no lone pair with larger bond angles. Therefore, we can hypothesize that for ammonia, the reason those bond angles are so much shorter is because that nitrogen is taking up some of the space. So where's the answer that says electron pairs take up significant space? B. Draw the electron dot structure for COCl2. This showed up twice in the worksheets. Carbon forms the largest number of bonds, 4, oxygen 2, and chlorine 2. If you're aware of the sort of generic structure for these, carbon with 4 lines, oxygen with 2 lines, 2 lone pairs, chlorine with 1 line, meaning 1 bond, and 3 lone pairs, the only possible way to draw it is like that. Structure of SF4, well, this sounds like a VSEPR question. Let's add them up. 6 plus 28 equals 34. That means we'll put 5 things on this, one of which is a lone pair, right? So that's kind of like, imagine a trigonal bipyramid, but one of them is a lone pair, and you got to attach that to that central horizontal region, making this seesaw type shaped. And does it have 1 lone pair of electrons? It does, right in the center. Hopefully we've drawn that. There it is. Have a look at this. These ones are always relatively difficult. There's your seesaw shape. Those would be the 2 things that stick in the sand, and Bobby and Sally, or whoever you want to have, are the 2 people on the seesaw. Which substance reasonable? Magnesium nitrate. Sounds fine, but we got a charge. Then NO3 is -1 and magnesium is +2. Not possible. C2H8, not possible. There's no way you can draw that and keep your carbon-carbon bonds or carbon bonds to 4. Magnesium oxide, that's fine, +2, -2. Calcium carbonate is just CaCO3. Where are you going to put that second calcium? I like C. And this is page 4 of the bonding review packet. No, bonding practice test.